we're going to continue working on oxidation states of carbon. So let's do, starting from where we left in our last video, but I'm going to draw now, say a whole series. So here, replacing one hydrogen by an oxygen, and then I'm going to replace two hydrogens by oxygen, for example. And I'm also, let's say, another example. This is another molecule. And now, let's do one more. This one. Here we have an alkane, an alcohol, a diol, an aldehyde, and a carboxylic acid. And we'll do the oxidation state of all that. And so as we did before, electrons are assigned to the more electronegative atoms. So those two are assigned to carbon, to carbon, to carbon. And here the math, we do 4 valence electrons, and then -2, 4, 6, 8. So oxidation state here is -4. Doing the same here, again, we assign the electrons to the more electronegative, but this time as carbon, is oxygen. And here, carbon between these two, so it's taking this two. And my math here is going to be 4 valence electrons, and then my count 2, 4, and 6 is -2. So in going from here to here, carbon is getting oxidized. So now moving on to this structure. And when I do that, again, between these two, electrons are going to the oxygen. Between these two, electrons will go to the oxygen. But between carbon and hydrogen, then carbon is more electronegative, so we're going to do that. And the oxidation state here will be 4 valence electrons, and then we count. And it's 2 and 4, 4 minus 4 is 0, oxidation state. And again, oxidation state here is going from -2 to 0, so it is an oxidation because the oxidation number is increasing as I'm going in that direction. Let's see what happened when we consider the change. Well, I'm not going to write an arrow here, but let's compare this to. So what happened if I go from here to here? So again, we follow the same strategy. We're going to assign electrons to, in a bond, to the one that is more electronegative. So this two will go to oxygen, and this go to carbon, and this go to carbon. And when I do my math here, it's going to be 4 valence electrons, and my count 2 and 2 is 4, is 0. And what I want you to see is that here the oxidation state of this two compound is actually the same. So this is not, it's neither an oxidation or a reduction. Now, oxidation state is not changing between these two, but it is when I go from here, say, to here, oxidation state is changing from -2 to 0. So following this arrow on the top, that is an oxidation. Okay? And conversely, if we look at the processes in the other direction, then it will be reduction. So if you go from here to here, carbon is being reduced. From here to here, it is reduction. And we said already that this is the same. So now let's do our last example. Our last molecule, we will have here oxygen being more electronegative. It's going to take the 4 electrons. Here it's going to take those 2. Carbon more electronegative than hydrogen. And my math will be 4 valence electron minus, and then only 2. So oxidation state is +2. And what that says is that if we go from here to here, oxidation state goes from 0 to +2, so it is an oxidation. But if I go the other way, then it is a reduction. My last molecule, let me do one more. Let's do carbon dioxide, CO2. Now again, we do the difference in electronegativity, which is where we are considering to assign electrons. So Oxygen is more electronegative. Oxygen is more electronegative than carbon. And when I do the math now, it's going to be number of valence electrons is 4, but then no electrons are assigned to carbon, so it's 0. So oxidation state is +4. So notice here in carbon, the most reduced oxidation state is -4, and the most oxidized oxidation state is +4. And you have a number of oxidation states in between. And we can also have molecules having several carbons in having different oxidation states in those carbons. So let's do one example here. I'm going to erase my carbon dioxide, and let's draw simply, let's say, ethanol. And ethanol is actually the alcohol that is the only alcohol that is suitable for human consumption. So here, let's name the carbons. This is carbon 1, this is carbon 2. And now assigning the electrons, because we're going to have to do oxidation state here and here. So for the carbon number 1, electrons here go to oxygen, but this 2 go to carbon, this 2 go to carbon. When we have 2 carbons, now the 2 elements have the same electronegativity, so there's no difference, so we're going to split that in half. 1 electron over here and 1 over there. And now between carbon and hydrogen, then carbon is more electronegative, same here, same here. Now let's do the math for carbon 1, oxidation state is 4 minus, and then we do 2 here, and only 1 here. See, 2, 4, and then 5. So because this 2, remember, went to oxygen, so we only count those 2, 4, and then only 1 because this is split in half. So that's why it's 5. So it is -1 oxidation state. Now let's look at the other carbon. The other carbon, 4 valence electrons. And now I see 2, 4, 6 electrons here and only 1 here. So -7. So that oxidation state here is -3. So notice the same molecule had 2 carbons with 2 different oxidation states.